Welcome to the Chemistry, Biology and Math Revision Hub. Today we're doing the chemistry lessons. This is alkali metals. So we begin with what are alkali metals. Alkali metals are group 1 metals of the periodic table, and they include lithium, sodium, potassium, rubidium, cesium and francium. We usually focus on the first 3 alkali metals. The chemistry of these ones is not usually studied. Francium is radioactive. This one is radioactive and is produced when uranium-235 decays. It is short-lived and is believed about 20 to 30 grams of francium are present in the whole Earth at a specific time. Due to that, nobody has ever seen a piece of francium. The chemistry of francium known by scientists has been predicted using the chemistry of the elements above it. So here we look at the physical properties of group 1 elements. Here we see we have ignored francium. We just considered those above it. For lithium, it has the highest boiling point among them, and its melting point is the highest. The density is the lowest, and it's going to be stored in oil. Oh, by the way, group 1 elements are very reactive, so we have to store them away from exposure to oxygen, because if they're exposed to oxygen, they react rapidly and produce metal oxides. Then we go to sodium. The boiling point is 98, melting point 883. The density is greater than the density of lithium and is also stored in oil. Potassium has a boiling point 63, melting point 760. The density here is abnormally lower. We can see the trend is not followed here and is stored in oil. Then we go to rubidium. We see the density goes higher. Now it begins to increase. This does not follow the trend. And with cesium, the density increases. So we can predict that the density of francium is going to be higher than that of cesium. The melting point of francium is going to be lower than that of cesium, and the boiling point is going to be lower. Also, we can predict that if we could find a piece of francium, we can store it in a glass tube away from air so that the metal oxide is not formed. So for the metals, lithium, sodium, and potassium, they are going to float on the surface of water because their density is less than the density of water, while those below that are going to sink in water when they react with it because their density is greater. Group 1 elements are very soft and they can easily be cut by a knife, and they become softer as you go down the group. They are shiny and silvery when they cut fresh, but they tarnish quickly. This is because they react with oxygen in the air. They are very reactive, and their reactivity increases as you go down the group. I'll explain that a little bit later. They react with air to form oxides, and they react with water to form metal hydroxides. So if you touch them with your hands, they will react with the sweat in your hands, and corrosion will occur because of the metal hydroxides that are formed when you touch them. Let's go to the chemical properties of group 1 elements. Here we are talking about things involved with reactions. Because they all have 1 electron in the outer shell, they have similar chemical properties. Remember, the outer shell electrons are the ones that participate in reactions. So if they have 1 electron in the outer shell, then their chemical properties are going to be similar. So they all react with water in the same way and they form metal hydroxides with this formula. They all react with oxygen to form oxides with the formula that, where M stands for the metal. They react with halogens to produce compounds which are salts. For example, sodium chloride, lithium chloride, where X is the halogen and M is the metal. They lose electrons to form ionic compounds with the formula M+, meaning it's going to be lithium plus, it's going to be potassium plus, and it's going to be sodium plus if reactions occur when they lose electrons. Their properties will depend on the number of electrons in the outer shell, like I already said. So they all react the same way because they have the same number of electrons in the outer shell. When they react with water, they produce metal hydroxides and hydrogen gas. And we saw already reactivity increases as you go down the group. So let's begin with sodium. When sodium reacts with water, because we saw the density of sodium was less than that of water, it's going to float on the surface of water and it melts into a ball. This is because when sodium is reacting with water, the process is going to be exothermic and a lot of heat is going to be generated. The generated heat is going to melt the sodium, so we'll see a ball formed. This is one of the observations you have to write when they ask you about what you see when sodium reacts with water. Also, hydrogen gas comes off from the reaction, so fizzing is going to be observed. Sodium is going to move on the surface of the water like hovering, like that. It moves on the surface of the water because hydrogen gas is formed around the solid. It's going to hover like that as the gas is formed. and this formation of hydrogen is going to be asymmetrically, so it pushes it around. Then we'll see the hovering movements. Sodium metal becomes smaller during this reaction, so this is another observation. The metal becomes smaller and it finally disappears. To test the solution that is formed, the indicator is going to turn blue color, indicating that the solution formed is alkaline, and this is going to be sodium hydroxide. Looking at reactions of other alkali metals with water, for example lithium, it reacts slowly than sodium because reactivity increases down the group, so lithium being at the top, its reaction is going to be slower. It does not melt into a ball because when this reaction occurs, less heat is produced. And during this reaction, we see lithium solid reacts with water liquid to give us lithium hydroxide and hydrogen gas, so fizzing is going to be observed. Moving on to potassium, it reacts faster than sodium because potassium is below sodium in that group. And the reaction produces a lot of heat that ignites the hydrogen gas. A lilac flame is going to be produced, and most times potassium is going to spit around and it's going to explode. So the reaction is going to be potassium solid reacts with water liquid to give us potassium hydroxide, aqueous, and hydrogen gas. With rubidium and cesium, the reactions are going to be more violent. Of course, cesium is more violent than rubidium because this is below rubidium. And when this reaction occurs, rubidium hydroxide and cesium hydroxide is going to be produced. I've just changed these from lithium to rubidium. There was a mistake there. So next we go to the explanation for the increase in reactivity. Reactivity increases as we go down the group because the atomic radius increases. Remember, it's the outside electron that participates in reaction, and this electron is held tighter when it's closer to the nucleus. The nucleus contains the protons, which are the positive charge, and the electrons are going to be the negative charges, so the attraction between that is what keeps the electron within the atom. So if this distance is farther, then it means the attraction is going to be weaker and this electron is going to be easily lost. So down the group, the atomic radius increases. The outer shell electrons that participate in reactions are farther from the nucleus. They are not strongly attracted by the nucleus, so they are easily lost when atoms go through reactions. We look at the main features of group 1 elements. They are all metals. They are soft and have melting and boiling points that are lower for metals. And due to their reactivity, they are stored away from air or water. They rapidly react with air to form coatings of metal oxide. And they react with water to produce alkali solutions of metal hydroxides and hydrogen gas. Their reactivity increases down the group. They react to form compounds with ions of +1 charge. They are mainly white or colorless compounds that dissolve to form colorless solutions. Finally, predicting the properties of francium. Francium is very soft. It has a density higher than that of water, probably about 2 grams per centimeter cubed. It has a melting point close to room temperature. It is silvery and tarnishes instantly on exposure to air. This is because it's going to be more reactive than all of them. It reacts violently with water to form francium hydroxide and hydrogen gas, and it is more reactive than cesium. It forms compounds that are white or colorless, and they dissolve in water to form strong alkaline solutions. So this brings us to the end of this video on alkali metals. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.